Alrighty. Well, thank you all so much for taking the time to join me to hear about my story making a Kubernetes home lab. It's towards the end of the conference. Towards the end of the day, so I really appreciate you spending the time. So I'm here to talk about Habitat and Kubernetes and how I used a home lab to learn about these technologies and what they mean for me as a technologist. Sweet. So first, a bit about me. Online, I'm known as PorterTech. That's my handle for IRC, Twitter, you name it. I'm a sysadmin operator by education and experience, and at heart. I'm the creator of the Sensu open source monitoring project. So it's been going on 8+ years for me working on that project, which has been really cool. I've been really close to the chef community throughout that time, and it's great to just come back here year after year and connect with all of you. So I'm CTO of Sensu Inc. and co-founder. It's a company formed around that Sensu open source project. We're around 35 people, and we're all over North America right now, and we just love making a useful, powerful monitoring tool for all of you. My hobbies at this time include cameras and whiskey. More cameras lately. I used to drink a lot more whiskey, but I'm already tired. As you can see, I have a 16-month son. He doesn't allow me to sleep all that much. So why Kubernetes home lab? Okay, so first of all, Kubernetes has pretty much won the container orchestration war at this point. Organizations that are moving to containerized workloads are definitely introducing Kubernetes into their technology stack or consuming a public cloud that offers it. It's becoming the cloud agnostic API at this point. And I think it's incredibly important for us, especially as operators and sysadmins, to understand and have a deep understanding of how these things actually work. I suspect a lot of people that have experience using Kubernetes don't actually know how their traffic is actually transmitted from one pod to the other. And for me to learn and figure this all out, the best way was to get my hands on it, get my hands dirty, and also play with some hardware. So this was a great excuse for that. So that's why I made a Kubernetes home lab, because we're all making a shift to containerized workloads using Kubernetes, and I want to make sure that I have a good understanding of that future platform. So in this talk, I'm going to talk about the hardware that I use to create my own home lab, the build process of actually taking it, stacking it all together, basic setup of how I provision the OS, installed Kubernetes. I'm going to talk about then storage, networking, and eventually get to Habitat on Kubernetes and what that looks like and some patterns for deploying your habitized packages onto Kubernetes. So everything I'm showing you today is in this Git repo. The README is extremely sparse at this time. But anything I show you on the screen will be there for your future reference. Also, as I'm going through this, it is being recorded. So if you miss certain steps throughout the process, don't worry. I'm sure Chef will have them up in no time, and you can reference them later. So hardware. I also made a video about this because it was fun. So I did a little bit of an unboxing video. So I bought 3 Intel NUCs, the Skull Canyon edition. And then I bought 3 250 gig SSDs for $40 a piece. And then about $45, this is Canadian too, so it's not real money. And an edge router, some patch cables. These were like $7. And then I found a perfect power brick that was the same size, and some double-sided tape. So here it is all laid out, and that's really it. I bought this off of Amazon. Again, this is Canadian dollars, so it's pretty cheap. But basically, I was able to get all this hardware for under $3,000. Now, you can absolutely build a home lab for much, much less. You can get Raspberry Pis and stack those, but I wanted to have hardware that was significant, that you could even run what could be a production workload on this thing. And I wanted something with a little punch, really. Also, they just look really cool. So what in the end, it gave me 12 CPU cores. They're like the Skylake 6770s, clocked down at 2.6. I have 48 gigs of RAM, 3/4 of a terabyte of SSD storage, and gigabit networking. It's pretty sweet. So the build. this is it after I pulled everything out of the boxes and laid it out on a table. I think my clicker might have died. No, there we go. So the Skull Canyon edition were pretty cool. They have this dope-looking skull on the front of it. They give you another plate that you can replace it. That's just all smooth, but there's no way I'm taking that thing off, so it stayed. There are 4 screws on the bottom of these things. That's it. If you remove them, you can get access to the motherboard. CPU is soldered directly onto it. You get 2 DIMM slots and 2 M2 slots, so yeah, I've got room for lots of expansion, but I wanted to keep it as low cost and distributed amongst the nodes for the time being. There are feet on the bottom of these things. I pulled them off, and you might say, that's crazy. You're going to cook your CPU. I had double-sided tape that, when added between these things, equated to the same air gap. So I actually just cut these 3M strips, laid a few strips on top, and glued these suckers together. So I could have done something like made a scaffold or something, a structure or a cage to hold them together. But again, I wanted to keep it low cost, wanted to keep it easy, as well as lightweight. I wanted this thing to be able to fit inside my backpack. I've been walking around all afternoon, even around Seattle, with this thing in my backpack. And it's held up quite well. It even survived the Canadian border and TSA inspecting it several times. Yeah, it looks really suspicious. I just didn't mention I worked for Huawei or something. So this is the power brick, which is just about as large as the NUCs themselves. So here they are on the podium, and they're also taped together. I took the Ubiquiti edge router and stuck it on the top, and then I took my 3 really small patch cables and plugged those suckers in. The power brick that I lucked out when I purchased it on Amazon was pretty much the exact same dimensions as the stacked power bricks that taped on top. So this is what it looks like, and I've got it set up here, and it's actually running. And I powered everything up, and it wasn't screaming at me, so that's a good sign. There's no alarms. So basic setup. So I've got the hardware all set up. It's plugged in. It's running. I had to first install an OS on this, so I threw it under my desk. This is my standing desk I use every day. To my colleague Eric, who's in the audience, I don't use a chair. That's the only way you can ensure that you're going to use a standing desk. And that's kind of where I spend my day-to-day. So I loaded up Fedora. There's a link on the bottom of this. The Fedora 29. 30 is out, but I was too much of a chicken shit to upgrade to 30. So I'm using Fedora 29 on this, using a live USB to boot. I don't have a KVM, so I just plugged an HDMI into the back of each of these and loaded up the OS that way. Once I installed Fedora, I just used the default partition scheme and installed it with all the default parameters. I edited Etsy hosts for a simple solution for my 3-node DNS resolution. Host 1, host 2, host 3, super generic. And I just chose a very generic subnet mask. And then I just set the host name of each of these. I did a yum update, and then I enabled SSHD. So then I was able to unplug my HDMI now that they're all live. And I had to set up the edge router. Unfortunately, I didn't have a Ethernet dongle at the time for my stupid Mac. So I pulled out an old Lenovo X240 with a Ethernet port and plugged into the router because I needed to initialize it. Once I got into it, the web UI is quite cool, actually. This is a screenshot from, I think, 4 weeks after I had the cluster running. But it gives you some inspection of the traffic that's actually going over the network and a lot of knobs to tune. It's a fantastic router, and I think this is actually the best router I've ever personally owned. I'm going to repurpose this for my house afterwards. So I could have statically configured the interfaces for each of the nodes. I chose against that just because I wanted to keep all my network config just through DHCP, and I statically assigned them within the edge router. You don't have to do this. But the most important thing is, do I have a laser with this? Oh, damn. No, doesn't work. You can see if you can read that, I had a very narrow range. I just wanted DHCP to start at doing subnet leases at 1.20 to 1.39. And I'll explain that later on. I had to set up some forwarding rules so I could reach my individual nodes from the outside world. And then I just went to the Kubernetes setup documentation. Instead of regurgitating the exact same steps here, you can simply navigate to that site and follow the steps just as I did. You'll just have to make a slight change if you're following along with my steps, in that instead of calling it fed master, it's just host 1. So what you get at the end of this, this diagram pretty closely depicts it, is that you actually end up with 3 machines running all the component, well, the kube proxy and the kubelet service, and then you have a single master running the API server, the controller manager, and the scheduler, and etcd. So I don't yet have a multi-master setup. If I wanted to make this fully HA, I would simply replicate that onto all 3 nodes. I wanted to keep it simple, and I suggest you do the same as well. So how Kubernetes works is it uses etcd for configuration and state and inventory. You have an API server that sits on top of it. That's how you interact with Kubernetes. You have the controller manager and scheduler, which basically says, hey, you kubelet over there, make sure that your host is going to run these containers in these pods. If you're not familiar with Kubernetes, I apologize. I'm definitely going to just skim over a lot of this terminology, but the unit of which you deploy software onto Kubernetes is called a pod. A pod can contain 1 or more containers. So storage. Docker supports several storage drivers. The default is overlay 2, and it is preferred. The only reason you wouldn't use this is if your kernel didn't support it. Do not use overlay version 1. It is not good. I, however, wanted to use LVM. Maybe my judgment's not great, but it has a driver called for device mapper that can work with direct LVM. It's actually supported. And on older RHEL boxes, that's actually what you'll be told to run for your bare metal cluster. So my Fedora host boxes are already using LVM. And I only used like a 15 gig partition for Fedora root. So I'm just going to reuse that volume group. So if you're not familiar with LVM, this is actually just a diagram. It's not the greatest diagram. I pulled off Google. But the idea is that you have 1 or more physical volumes that are sliced up and then associated with 1 or more logical volumes. And that's kind of what you want to do. And what's great about it is that you can actually grow volumes after the fact, and it's quite flexible. So Docker can leverage the thin provisioning and snapshotting capabilities of Device Mapper. It's pretty sweet. Both the driver and direct LVM uses block devices, and we can actually create a thin pool, and that's exactly what I did. But first, because I'm redoing Docker storage, I have to tear everything down or hit it all with a flamethrower. So that's what we got to do first. So we got to stop the kubelets, because we don't want them to stand up additional containers or pods that contain containers. We have to stop Docker, and then we're going to blow away any of the Docker state. It's fine. It's fine. No one's using this. We're going to create a logical volume. We're just going to call it Docker. We're going to create one for the metadata, and then we're going to create a thin pool called Fedora Docker. Then we're going to configure we're going to configure it to automatically extend when you hit these thresholds. And then we're just going to, let's see the next one, configure Docker to actually use the device mapper storage mapper, as well as using the new thin pool we just made. So it's just going to provision additional space as it needs it and grow with Docker's utilization. And then we're just going to make sure that we're going to run Docker info to make sure that we successfully configured it. And then we're going to start up the kubelet. And that's it. And this was actually quite smooth. I fully expected to hit a snag while doing this. And Docker just came up, kubelet came up, and then I was able to create pods no problem, and it utilized the disk space, which is great. So Kubernetes imposes some fundamental networking requirements. So the first is that pods on a node can communicate with all other pods without the use of network address translation, or NAT. Agents on a node can also communicate with all pods on that node. So agents on my physical host, such as system daemons or the kubelet, can communicate with the pods on it. So there are really 4 types of networking. The first is highly coupled container-to-container communication. This is essentially solved by Kubernetes pods. When you run more than one container within a pod, they can communicate with each other over localhost. 2 is pod-to-pod communication. That's what I'm going to talk about first. So there are a number of plugins for Kubernetes for networking. And some of them require actual hardware. Some of them require you to talk to a vendor and purchase something. And then there are pure open source software-only ones. And I actually chose the bottom one down here, Flannel. There are many other options, and you can visit that link to see them all. But Flannel is my choice. The reason why is that you just run a flannel-d daemon on each host. And what it does is it allocates a subnet lease. It gets a subnet lease for each of your hosts, which is pretty cool. It can use the Kube API or etcd directly to do configuration. In my case, I just used etcd directly. And then it basically handles packet forwarding between hosts. So a pod on this on host 1 can talk to the same pod on host 2. And it has a number of drivers to enable that. A really YOLO implementation over raw UDP encapsulation, host GW or VXLAN. So I chose to use VXLAN, which is what the documentation also suggests. So this is kind of what it looks like. This is another diagram. I just couldn't find the time to make a diagram myself. So ignore the actual address ranges. But I wish this laser pointer worked. The pod network in that middle, that green slice, is the overlay network. And that's what VXLAN is actually creating. So when a pod on one wants to communicate to an address of a pod on another, it simply creates a virtual, not simply, but it uses a virtual tunnel over to the other machine. It does further packet encapsulation and basically wraps it all up, sends it to the other host. It unencapsulates it or unpacks it, and then forwards it to the correct pod. And this all just happens under the scene. And like anytime we're using like Google Cloud or AWS or even like another, like a DigitalOcean's Kubernetes, these sort of things are always happening under the covers. We simply just don't see them. To install Flannel is super easy. Just to install Flannel, basic configuration for Flannel-D, we're just going to point it at etcd on host 1, the same etcd that Kubernetes is using. And then I had to make sure that I added this IP table forward except, otherwise Flannel simply did not work. And in fact, to make sure that this worked every time I shut this thing down, threw it in my backpack, and then stood it up elsewhere, I just threw it into a unit file just starting after the kubelet to also make sure it's set. The reason why I didn't just do like IP table save or what have you is that Kubernetes itself is managing those tables. I just didn't want to mess with it. Flannel config, I chose the documentation's default. I didn't make a decision here. Well, my decision was to use the default. And you can do the same. This is it. This is all the configuration you have to do for Flannel, which is fantastic. So you can see I specify my backend VXLAN and give it a number. I'm just using 18.16.00 and a /16 something. Actually, on the back here, this is how you do the configuration, that last line. I'm just using etcd-cuttle and just dump that JSON into that key space. All right, so then I had to stop Docker again. I deleted the Docker interface. I enabled Flannel-D, and then I started up Docker. But I ran into a problem. Everything broke. It's also a great movie. Gotta watch that one again. You have to update the API server with the server cluster, or service cluster IP range to match that of Flannel in order for this to work. Otherwise, it simply won't. Just stop the API server, stopped etcd, blew out etcd, which was fine because I didn't have anything running on the cluster. If I did, that would be problematic. You could be more surgical and actually just remove the specific keys, but this was the only way that I could ensure I had a clean operating environment. Start etcd back up, reset my final config, start up the API server, and it was working. That's also it's not a great movie, but pod to service. So that was pod-to-pod communication, and Flannel took care of that for us. Pod to service communication, it's DNS. So thankfully, you get kube proxy for free with Kubernetes. And that allows the addresses to work for the service. But we need a method of doing service discovery so that your pods can communicate with those services. DNS is the way to do that. There's core DNSs, which is a fantastic, simple piece of software that's extremely extensible. And you can get plugins for pretty much anything, including service discovery for Kubernetes. And what's great is core DNS provides a Docker image for just this purpose, which made setup super easy. To follow these steps, you can clone my Kube home lab repo, change into it, and then you can look at the config. I think I jump into it there. So this is the full config, but if we just drop the Kubernetes metadata, we can see a little bit more. You can see we're just, it's a really simple, straightforward configuration. We're saying this is how you're going to resolve DNS, and forwarding, we're going to use Google DNS, and expose your Prometheus metrics, and have a small cache, and load balance. So if there are multiple records, you just load balance round robin between them. Super simple. We create this config map first, and then we simply do the core DNS YAML, which does a deployment, which has 2 containers, and it has a service, which gives you a cluster IP. And this IP is really important. And so what you need to do is copy what you end up with, and then you need to update the kubelet to use that for cluster DNS. Once you restart the kubelet, it'll break. So my experience has been like, I'm following along all these guides, and I think I'm going to just like have everything working. Every time it's like, you're done, it would just not work. So that's why I really wanted to share this experience with you, because don't be discouraged if you experience the same thing. I'm pretty sure everyone runs into the same issues, or I'm unique somehow, and I can feel special in that way. All right, so I need certificates, proper SSL certificates for Kubernetes for the API, as well as I need a service account key for the controller to interact with Kubernetes. So the documentation is actually fantastic for this. You can just use OpenSSL, generate them all, and follow these steps for the service key. And then we'll just configure the API server to use these certificates and that key. We'll also do the same for the controller manager. And then we're going to restart the API server and controller manager. And everything's alive again. No big deal. The last bit, our networking, was external to service communication. And this one's really interesting when you're running a bare metal Kubernetes cluster, because we don't really have a load balancer or the equivalent of like AWS with ELBs, or a load balancer on Google, for that matter. But there's a great project called MetalLB, which actually just leverages the already existing Kube proxy, and it handles allocating IP addresses to services, as well as it runs a speaker daemon essentially on all your hosts to take care of ARP for you, which is really cool. Super lightweight, really easy to install. Again, just from my home lab repo, I have a config map for you, which is doing a layer 2 with a range of 140 to 1250. And again, earlier I mentioned that I only had my edge router doing DNS for a very short part of the range, and this is why, because I reserved this chunk for my Kubernetes services. There we go. Actually, I have a slide for that. So I worked that into how I was doing DHCP. For the config, I just applied it, and then I did a deployment, and a whole bunch of magic happened. And I now had routing from the outside world to my Kubernetes services, to my pods within, and my pods could all communicate with one another. So Habitat, I've got a Kubernetes cluster now, and everything's working. I've got my storage, my networking, all operating. Now I want to deploy an application onto it. So Habitat, oh man, the slide is jacked up. All right, well, I don't have a Windows machine, so I couldn't have done this. All about lifecycle. So for me, Habitat is all about the lifecycle. It's all about how you build your app, how you deploy it, how you run it and manage it on a production and system, and how you upgrade it as part of manage. You create a platform-independent artifact, and oh man, I even lost bullets. Yeah, this thing is just, yep, never mind. Moving on. So the Habitat team provide these awesome diagrams of how it all actually works. And effectively, you end up with a ring of supervisors that all gossip amongst each other, maintain a peer list, and you can run your services upon it. You can use it for effectively service discovery, and you can do some really cool things with topologies. So you can have everything either a standalone app, it doesn't really care about anything else, or you can even you can set up like a relational database with, leader-follower replication. And what's really neat about this is that I can build a package and I can deploy it out onto this and I can upgrade it in place. And I'm sure a lot of people have already talked enough about Habitat the last few days. But what I ended up wanting to do here is integrate with Docker Hub as well. So I could use Habitat to package up an application. It would push to Docker Hub, and then I could have Kubernetes just pull it off the hub. What's really cool about the Habitat project is there's also a Kubernetes operator. The operator is designed to solve the problem of how you run and manage Habitat services on Kubernetes. It uses a CRD, or a custom resource definition, as a further higher level abstraction above Kubernetes to describe your rollout of your application. It runs on a single pod. Demo. So I wanted to just whip through that deck real fast because the real fun is actually using this thing, this Frankenstein that I've created. I've got a really cool board here. Let's see. Magic. All right. Cool. So here's my project, the home lab, and there's my super sparse README. I owe it to all of you to update this from my notes document. OK, so here I've got my terminal. Hopefully you can read that. Actually, is it possible to dim the lights in here at all? I don't know if I can brighten this up. I'll make it a little larger. OK, so I've got my 3 hosts, which are running. I'm just SSH'd into each of them. And what I'm actually going to show first is so kubectl is the CLI tool for Kubernetes. And if I run just get nodes, I can see I've actually had this cluster for 40 days. It's impressive. All right. I've got 3 of them, and they're all ready. So if you followed along with the steps and those guides, you too would be in this situation, for better or for worse. OK. Oh, look at that. Got mood lighting now. All right, so I have my Kubernetes cluster, and it's up and running. I'm actually going to jump out to show you a really cool website that hasn't been updated since 2013, which is my blog. So I felt it would be funny to use the stereotypical example of, like, here's a blog I created many years ago and haven't updated it. So I'm going to take this app, which is a Ruby app. I'm going to package it up with Habitat, and then I'm going to deploy it out into Kubernetes. I have links for this. So here's the repo. I actually created this and went public a few weeks ago in preparation. But what's really neat is I just created a directory called Habitat. Within it, I made a plan file, and that's it. That's all I had to do to package this thing up, is a hab package. I then jumped onto Builder. And on Builder, let's see if I can make this work. I just clicked the button, connect a plan file, and I pointed at my Git repo, and magic happened. I ended up with build jobs, and it would just create and build these things for me. And let's see if I can get this build output. Sweet. So it actually goes through the process of determining what all my dependencies are, and packaging and building it all up for me. And at the very end of it, God, that's a lot of output. All right, come on. Oh, yes, thank you, smart man. All right, if you jump to the end, which is the best part, it creates a container for me. And that container is then published to Docker Hub. That's pretty sweet. What's awesome about Habitat is it also gives you a local studio. So if you run Hab Studio, it basically runs a Docker container, and you can interact and build your application locally as well. And you get a number of ways to export your package, whether it be a Docker container or a different format, for your deployment. In this case, I just wanted Docker, and Builder pretty much did everything for me out of the box. I didn't have to mess around too much. There was a few bugs with Builder at the time, but the team helped me fix and deploy those onto the Builder in no time, which was really cool. And it was great to see that happen so quickly. All right, so actually, if we've got that Docker image out there, I think it's just on. I've got another link for this. There we go. So we have the Docker image. This is public too. You too can run my blog if you like. That's out there on the internet. I would appreciate a post once a week, please. So you can use this as well. So it is Ruby app, and it pulled in Ruby 2.5. and a number of dependencies, everything I needed to run, and it created this container. And also includes Habitat Supervisor within, which is really cool. All right, and what's really cool is that, let's see if we go into Kube Home Lab. So by default, the Hab tool also gives you the ability to spit out a CRD for the operator, which is really cool. I'm just spacing out right now. So that's the bottom of it. So it's really cool. So this is the CRD for the Habitat operator. So I've got my container image. I need my resource definition for Habitat, and it could generate it for me. We can see here, normally it actually pins your version of the container, but I love to live dangerously, so I'm using latest. I want three versions of my app running on Kubernetes, and because I have 3 nodes, the scheduler, you would assume, would put one container or one pod on each host. You have to give it a name. The topology for this is my Ruby app is fairly stupid. It doesn't do anything, so it can be standalone. We don't need to do any clustering or anything along those lines. I had to pass this environment variable to accept the license in order to run it. I don't know if I could have done something differently at build time to avoid that, but here we are. And then I'm going to create a Kubernetes service that exposes my application on port 8000. And by doing this, MetalLB will allocate a IP address so that we can access it. Core DNS will have a record for the service so we can discover it, we can find it. And Flannel will deal with my pod-to-pod communication, which this app simply doesn't do. All right, so what we need to do first now is actually deploy the Habitat operator. And I'll do that now. Let's see. So what I'll do while that's happening is I'll show you what this looks like. So Kubernetes also has a full RBAC model, and the Habitat operator out there has all this documented for you. You can simply just curl and pipe it from the internet if you like. But I like to read what I'm putting onto my systems. So this is essentially it. We have a single deployment that runs a container image. Super simple, which is really great. So now if we do kubectl get pods, we should see our Habitat operator is running. OK, good. Yeah, I successfully came from my hotel room, walked around Seattle for 2 hours, and then set it up here, and Kubernetes is still working. So that's a good sign. All right, so now all we have to do is kube apply, kube, Habitat. Let's deploy my blog. This is the version for the operator. All right, and we just hold on to our butts. And we can see it's created a stateful set. So we should get our 3 nodes. Oh, lordy. All right, we'll let that leave. So what I did for this demo is I'm bridging my Wi-Fi from my laptop to the cluster. So if any of you are downloading iOS updates, please stop. You can't stop them. Apple owns you. All right. Yeah, so what it's doing is actually fetching the latest container over this very speedy Wi-Fi. All right, well, that's happening. So one interesting thing about this is that the operator doesn't support multiple containers per pod. And that's problematic for a number of reasons. One is that if I want to monitor and collect my logs for my pods, I have to use a daemon setter, expose that information via another way, or pull from the Kube API. I can't run what are called sidecars. So the way around this is to simply not use the operator and to use a different pattern called a Bastion. Are we calling it the Bastion pattern? Bastion pattern. All right. So Irving has shared this set of plans, and he updated it 4 hours ago for me. Thank you, Irving. Everyone give him a round of applause. And what this does is it basically stands up a Hab supervisor ring, or just a single machine, that is persistent and always there. So then when I create my own deployments, it's simply, I just add it to the peer list. And this is great for a number of reasons. I can now do some interesting things. Actually, right now, I'll go ahead and show you what that looks like. So the Bastion deployment is super simple. I'm very trusting. I have no idea what's in this container. It's all good. And this is, yeah. And then this is the important arg. You run it with permanent peer. You don't actually have to limit resources for it. And then we expose the number of services from Habitat. And then we have a Kubernetes service. We're not actually exposing this as a cluster IP or to the outside world. It's simply for internal purposes only. This is simply to solve the service discovery problem. Again, you can jump into this and learn a bit more, go deeply on your own time. And what this allows us to do, though, is we can now use Kubernetes resources. So we're no longer using the Habitat CRD, which is unfortunate. But we can use our regular Kubernetes resources and do a deployment. And then this is the bit that's important. So I used a fully qualified domain name for that service, for the peer, and that simply allows it to stand up and work, which is really cool. And then I can do some really neat things, like I can add my monitoring and my logging agent as sidecars within this pod. And what I've done here is actually added the Sensu agent, which is really cool. OK, is this broken? Yeah, it's broken. Aww. Sad. OK, what we'll do is, well, let's find out, actually. Oh. Sweet, thank you. Yeah, we're pulling image, so come on. It'll work eventually. And that also means that, all right, while that's waiting to pull, we're gonna deploy Sensu. So Sensu is a monitoring tool which has two components. It has a backend for processing data, and it has an agent for collecting information via APIs and service checks and really cool things. So what I'm going to do is go ahead and deploy a Sensu cluster. This should work because I've pinned my version and everything. OK. Get pods. So this one we deploy into a separate namespace called Sensu system. Look at that. Look at that. Didn't need the network for that. All right, so now I have the Sensu Cuddle tool, which, like kubectl, is just for Sensu. And I think these, I've already gone ahead and port forwarded through for NAT. And then I'm going to use the super secretive default username and password. Yes, Sensu Cuddle, entity list. So entities are effectively the inventory list for Sensu. Currently, nothing's being monitored. You can see we've got 3 backend nodes. They're actually all clustered, so they're in an HA configuration, and I'm able to successfully communicate with it. So let's see if we've got our thing to monitor yet. Ah, there we go. Sweet. So now what I can do is I can jump over, and I can view my blog. So this is running, this is the habitized, is that the right terminology? Yeah, habitized version of my blog. That still hasn't been updated since 2013. Running on our Kubernetes cluster, and it's being load balanced by MetalLB, which is pretty rad. So that's step 1, but I can't really effectively monitor this the way I like. So what I'm going to do is I'm going to go ahead and deploy the Bastion. Let's see. It's in Habitat. Habitat Bastion. So Irving's containers out there on my personalized cloud. So we can see that. It's up and running. Sweet. We're going to go ahead and deploy yet another version of my blog. It's never been read this much in a long time. Bastion. So this is the version that's not using the operator. It's not using the CRD. I'm just using Kubernetes language. And I think I have, here we go. Got the Bastion version. So this one is also running. And what's cool about this is that I've also exposed Prometheus metrics on, oh, that's great. Never mind that. Everyone look away. Avert your eyes. Let's see. It is on a weird port because it would collide with the other one. So it's still running, but let's see. Oh, wow. Let's make sure that we're actually running. Oh, it's still creating the containers. The interesting thing is the load balancer was sending me to a pod that wasn't ready, so that's something I have to configure. Oh yeah, and as a note, MetaLB, it's sticky sessions, so I'm forever stuck. Get services. Just make sure that port is also right. Bastion, 45. Yeah, this is natted through, though. All right, well, let's deploy monitoring and see if monitoring determined if it's up. All right, so what's really cool is that we can go ahead. Oh, actually, if we do a Sensu cuddle entity list. Oh, no, let's do this first. Let's create a namespace in Sensu. So Sensu is also multi-tenant. Oh, no. I should just type this out, but I'm too lazy. There we go. We're going to set our default. I don't even have to. OK, so now if I do a Sensu cuddle entity list, there we go. So we can see our habitized blog also has a sidecar with a Sensu monitoring agent in each one. They have successfully registered themselves with the system. If I kick it over to, hold on, time. Oh, sweet. The Sensu web UI, which is part of the backend. I can log in. I can switch over to the Kubernetes namespace. I can see my 3 agents are checking in here. If I click on them, I can actually see some information about them. I can tell that they're Linux. It's packaged as Alpine for the agent, and a few other things. So let's just quickly deploy a check. Sensu cuddle, create -f, Sensu. Actually, we need some check dependencies first. Let's do a really basic one. Let's just do an HTTP check. Yeah. And then we can create a check. So these, I'm just loading in YAML. Much as you interact with Kubernetes, you can do the same with Sensu. They're simply just different resources. So we probably want this one. Alrighty. So now if we do a Sensu cuddle asset list, we can see we've registered this. What an asset is saying this check uses this web asset. This is its 512 checksum, so we can verify its integrity. And what we can do is we can associate it with a check. So here we've said there's a check called portdetect blog HTTP. It depends on the check plugins asset. So when an agent goes to execute this, it'll go, oh, I don't have that asset. It'll fetch it from the web, verify its integrity, unpack it, and then it'll run the check with that as a dependency. So you have like dynamic dependency for your monitoring dependency delivery, which is really sweet. Let's go see if we've got, are we in business? Are we working? We've got a check. Oh yeah, they're all fetching that asset from the internet. That's why they're slow. There we go, 3 entities, 3 agents, 3 keep lives. Don't have any checks yet though. There we go. So we can see now we've got monitoring for a HAB application, which is really cool. And then one thing I just want to point out before we're out of time is Sensu assets have Bonsai, which is effectively like the supermarket for Sensu. If I search Habitat, there's actually a community plugin which integrates with Habitat, and it's able to talk to the API and determine whether all of the services are healthy, which is really cool. I wanted to use it for my demo, but I ran into a Ruby bug, as one normally does. So I wasn't able to use it. But that's kind of it. So I really just wanted to like walk through, actually I got to switch back over to this thing. I really wanted to walk through my experience in creating the lab, how I created it, a little bit about it. And for me, what's next is really I want to solve some of these problems to make it really production ready so I can open it to the internet. I need API authentication, persistent volume storage. I may have solved my Docker storage problem, but I still need persistent. I might do network attached for that. I want to do more topologies with Habitat, deploy more complicated applications to get a better understanding of how that works. I want to play with policy on the network with Calico, and I want to play with things like Istio service mesh. So here's some more pictures of it. It is pretty sweet. I love this little thing. I also just want to say the Sensu Summit, if you're interested in learning more about Sensu, you can come talk to me after this talk. As well as we have the summit in September, which is a great event in Portland, a great excuse to be in Portland in September, and there's also lots of great beer. So thank you so much for sitting through all this. I hope this was interesting to you and helpful, and really I hope that you too will go through this exercise of creating a Kubernetes home lab for your own experiments. Thank you.